Hey there everyone, myself Abhishek Nigam from ECE Department, and today I am going to discuss one of the most important topics in our ECE Department, that is Melde's experiment. So basically it's an experiment that we are doing for determining some amount of waves that are present in our nature. So basically I'm just going to show a little bit of a part of it. So here we go. So basically we have two modes of vibration. So one is longitudinal mode and one is transverse mode. So let us go to the next slide. So actually in this experiment we are going to determine the frequency of an electrically maintained tuning fork using two modes of vibration that are known as transverse wave, and another is the longitudinal mode of vibration. So this small thing is called a tuning fork, and it forms a loops like called 8. So you can see, right? So these are the string oscillating at frequency f0, and the terminal parametric frequency 2f0, and this is a small cuboid like structure. So this is main setup. So here is the definition of speed of a wave that is present in the stretched string. So a mean wire of fiber which has uniform diameter, which is perfectly flexible. So the speed of wave in a tension should be stretched string, depends on the tension. So the mass per unit length, it is given by V is equal to T by M the whole power 1 by 2. So where T is called the tension of the string, that is equal to mg, M is the total mass suspended, G is acceleration due to gravity, M is linear density M dash by L, and L is the total length of the string. So the vibrations that are actually present in the string are given by this small definition, and this small part you can see, right, this side, it is called a node, and the higher peak you can see, right, it's called as an antinode. So combination of this gives us the vibration that is given by L is equal to modulus L by 2, and this is the frequency of vibration given by V by 2L. So this something we get F is equal to 1 by 2L into 1 T by M into 1 by 2 Hertz. So we have transverse mode of vibration. So in transverse mode, actually the vibrations are actually in the direction perpendicular to the string. So it will be somewhat like this. So here the frequency will be 1 by 2L into T by M the whole power 1 by 2 Hertz. So this is the formula given by for transverse mode, and for longitudinal mode it is given by F is equal to 1 by T by M Hertz. So you can see that the 1 by 2 is power 1 by 2 has been replaced. So this is actually longitudinal mode. So it's nothing, it should be in the same direction of the vibration or parallel to the length of the string. So this is the small difference. So guys, this is the basic experimental setup. Here we have the socket boards arranged, and then we have the Melde's electrical vibrator, and here we have the NV6056 Melde's electric motor. So here we can see the setup, right? So here the coils are looped and the obtuse to it, and the pulley is present, and this small guy is actually called the Melde's apparatus. So these are the two waves we are going to operate on, transverse wave and longitudinal wave. So these are a few steps, 7 steps that we are going to follow in this video. So we should select the mode of vibration. The transfer voltage is adjusted 8 volt. The mass is on and off. Length is measured by using scale, using equation. By repeat the experiment by changing the parameters. So this I have given small rough values. So we have to just tabulate like this, and we have to try to get the frequency average like this. So this guy are in this slide we can see that there are graphs which I have drawn. This is for transverse mode of vibration and longitudinal mode of vibration. So you can see that in that we have plot between tension versus I square M square. So we have to never forget the formula. F power 1 by 2 is equal to 1 by 4 mu into 1 by slope is given for transverse mode, and for longitudinal mode we derive it by F the whole power on F power 2 is equal to 1 by mu into 1 by slope. So these two are important formulas for us. So after all this, we get the result as the frequency that is electrically maintained in the tuning fork is found to be 50 Hz. So it's quite simple, right? So it's not too difficult. So after following these quite simple steps, we can easily determine the value of Melde's experiment, and it's not too tough. So thank you for listening, and have a nice day.